I'd like to ask you a question. Is this true? 2 plus 3i equals to 5i? Well, I sure hope you say no. Why is that false? Because these are unlike terms. It'd be the same thing as saying that 2 plus 3x is equal to 5x. They're both wrong, aren't they? Because they're unlike terms. So I want you to remember this by the time I get to the end of this video clip, because I want to point out to you a very common mistake students make, and they actually make this mistake on tests. Lose a lot of points that way. And so, and the reason I think they make that mistake is because when you have decimals, then you tend to overlook the fact that if these were decimals, for example, suppose it was 2.349 plus or minus 1.887i, it's easier to overlook the fact that these are unlike terms and cannot be combined. Same up here. So we can't combine 2 plus 3i any more than we can combine these two terms. So I'm going to come back and remind you of that at the end of this video. And I would sure love to give a test someday and intermediate algebra where no one made that mistake. But unfortunately, no matter what I've done through the years, I've never been able to convince the whole class to avoid this mistake. So, alright, so here's a back to earth here. Let's do a problem. We're going to solve 2x squared plus x plus 7 equals to 0. Let me get my head around this. Yeah, that'll work. Alright, so, okay, a equals to 2, b equals to what number? I'm using the quadratic formula here to solve this problem. Well, the coefficient of x is 1, so b equals to 1. C equals to 7. So we can plug this into the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. I don't think I'll ever forget that formula as many times as I've repeated it in my lifetime. But we plug the numbers in. X equals to minus 1 plus or minus the square root of b squared, 1 squared, minus 4 times 2 times 7, all divided by 2 times 2. So here, under the radical, we get 1 minus 56, so that's negative 55. Don't ignore those negative signs. So x equals to negative 1 plus or minus the square root of negative 55 divided by 4. So we're about ready to write the exact symbolic answer, because I can factor out the I from the square root, but the square root of 55 does not simplify. I can't reduce that. So let me write the answer up here. X equals to negative 1 plus or minus I times the square root of 55 divided by 4. And again, this is the exact answer, exact symbolic answer. Alright, so now let's talk about calculating the decimal approximation. So it's a little different this time because I can't combine these together. In other words, if I wrote these separately, x equals to minus 1 plus I times the square root of 55 over 4 minus 1 minus I times the square root of 55 over 4. It's not so useful for calculating purposes because I can't combine these together. Remember, this one has an I in it, this one doesn't. They don't come together. So here's how we handle the complex numbered answers. We're going to split it up differently. X equals to minus 1/4 plus or minus the square root of 55 over 4 times I. So I split this up into the real part and the imaginary part. And now we can pull out the calculator for the approximate answer. So X is approximately negative 1/4 is negative 0.25 plus or minus, and I'll need the calculator for this one. So the square root of 55 divided by 4 is about 1.854 times I. And remember, if you need to round up, you need round up. Okay, I expect you to round numbers up when it's called for. All right, so here's our approximate answer. And notice that I did not attempt to combine the I part with the real number part. Again, they don't mix. It's like that 2 plus 3I cannot be simplified. So I wanted to, at the beginning of the video, I talked about that. So that's as far as we can take this answer here. So the problem is fully worked.